From San Francisco's Golden Gate Bridge, you throw a heavy rock downwards with an initial speed of 2 meters per second. How far does the rock fall in 3 seconds? We always start by pulling out of the word problem the relevant information that's been given to us. We are throwing an object downwards, so our initial velocity is negative 2.0 meters per second. The negative sign indicates that the velocity is downwards. We're defining up to be positive, our usual convention when we're dealing with the vertical dimension. How far does the rock fall? How far? So delta x is our unknown. That's what we're being asked to find out. In 3 seconds, our delta t is 3.0 seconds. And because San Francisco is on the Earth, the acceleration of the rock will equal the acceleration due to gravity of negative 9.8 meters per second squared. The fact that we're told it's a heavy rock means we can ignore the effects of air resistance. It's just not important if the rock is heavy. Let's go ahead and write our equation for the distance traveled if we have something with an initial velocity, v0, and it's accelerating. So delta x equals the initial velocity times time plus 1/2 a delta t squared.
So we have negative 2 meters per second times 3 seconds plus 1/2 times negative 9.8 meters per second squared times 3.0 seconds squared. Negative 2 times 3 gives us negative 6 meters plus negative 4.9. Our units cancel here, the seconds cancel, we're left with meters. Second squared here cancels second squared here, so we're left with meters. So negative 4.9 times 9, and so that gives us negative 6.0 meters plus negative 44.1 meters. But we really only have 2 sig figs here, so I'm going to write that as 44 meters. So we have negative 50 meters, 2 sig figs.
Negative 50 meters is the change in position of the rock. It is 50 meters below where we threw the rock. A follow-up question to this is, at this moment, 3 seconds after being thrown in the downward direction, how fast is the rock moving? We're going to use our acceleration equation. Delta v over delta t is our definition of acceleration. Therefore, delta v is equal to a times delta t. And our delta t is 3 seconds. So we have negative 9.8 meters per second squared times 3.0 seconds. Seconds here cancels one of the 2 seconds on the bottom of meters per second squared, and we are left with negative 29.4 meters per second. Now keep in mind that is delta v, the change in the velocity. Remember, a change in the velocity is the velocity at the moment we're interested in minus the initial velocity. So really what we have here is v minus v0 is equal to delta v. So v is equal to v0 plus delta v. And our v0 was negative 3.0 meters per second.
Plus negative 29.4 meters per second. So that gives us negative 32.4 meters per second. And in the end, we really only knew the negative 29.4 as negative 29 because of 2 sig figs up here. So negative 29 plus negative 3 would give us
negative 32 meters per second.